Hello, welcome everyone. Today I'm going to be walking through some of the example TypeScript code just so I can cover some key features, explain what's going on, and that should help you if you want to refer to those examples when you're building your own bots. Okay, I'm going to look at the OpenAI integration bot that I've created because I think it covers a lot of the main features of the framework while still being relatively simple and easy to understand. So let's get started. I think I will change to a darker theme. Just so you can see more easily. Yeah, I think that's better. And then let's increase the font size a bit. Okay, so you'll see in our bot framework repo under the TS examples, we've got an OpenAI folder, and that's where we're going to be looking for the code for this bot. So let's start with the definition. Well, in fact, let's start at the beginning. The entry point for this bot is the server. This is just a simple express server. We run .env to pull in environment variables from an env file. That's going to become important for telling our bot about various bits of environmental configuration it needs. And then in our app file here, you see this is just a pretty simple Express.js website written in TypeScript. So we create our Express app. We're adding a CORS middleware here, which allows this bot to be called from any origin. Different frameworks will have different ways of doing that, but it's quite important because this bot's going to be called from the OpenChat front end, so it needs to allow that. You don't have to allow any origin, you can restrict it to the specific OpenChat environments that you're working with. And then we have a few other endpoints. We have execute command, and that is designed to help us accept commands from the OpenChat UI itself. We have notify, which is enabling us to consume events from OpenChat. More on that later. And then we have the bot definition endpoint, on which we return the definition of our bot. And then we just have a fallback, which is also going to return the bot definition, although that's not a requirement. So let's start by looking at that schema or definition. So this is essentially just returning some JSON that describes the commands and the autonomous behavior of our bot. A word on how you understand what this definition looks like. You can the easiest way for a TypeScript developer here is to simply look at the types. So if you've installed the OpenChat Bot Client TS package, pull in this bot definition type, and then you can just go have a look at it. To see how it's defined. And now my VS Code is going to hang for 30 seconds while it attempts to analyze that file, which is annoying. But we can see it's got a description. It's got a specification of the autonomous config, and what this means is what we're expressing here is the permissions that we want the bot to have when it's operating autonomously, and by autonomously we mean when it's operating not in response to a user command. And we'll see that in action in due course. So here we're saying that this bot needs to be able to write text messages, and it needs to be able to react to messages, read chat details, and delete messages. Note that it doesn't mean that when someone installs this bot, of course, they get to choose which of these permissions that they actually grant the bot. It doesn't necessarily get the permissions that it asks for. Next up, we have default subscriptions. Now, these are the types of event that this bot wants to listen out for, and that refers back to this notify endpoint. That's where events that occur within OpenChat will be sent if the bot has subscribed to them. So this bot is listening out for chat message events. And then finally, we have the description of the commands that this bot supports. In this case, we have a prompt command, which is just like a kind of normal AI chatbot. You send it a prompt, it sends you the answer. We have an imagine command, which is to do with generating images via the API. And that's it on the command front. The only interesting thing about this prompt command is that it has this direct messages true flag, which means that if we install this bot as a direct chat, we can simply enter our prompts in the text box without entering the /prompt command, and it will feel more like a natural conversation. So let's also just have a little look at this. So here's my local development environment. I've got this group set up. Inside this group, I have installed this bot, and as we just saw, these are the commands that we have available to us. And it works kind of like you would expect. Prompt. And off it goes and gives us the answer. And look, there's also a reaction here. I'll explain where that came from in due course. So let's take a look at the code for that prompt command. And let's just follow this from the top. When that command arrives, it hits this execute command handler. There's a couple of things going on here. We add the text middleware. That's because what we're expecting to have in the body of this request is simply a JWT, an encoded JWT. Now, we don't have to understand that ourselves, and that is what this second middleware is doing. So let's look at that. Create command chat client, and it's passing in this thing called factory. So let's see what factory is first. Factory is a factory for creating clients which are able to talk to the OpenChat backend. You can see here that we're initializing this factory with various pieces of information that come from the environment variables that we've injected into our system. We've got the OpenChat public key, the internet computer host, the private key that represents this bot's identity, and the open storage canister ID, which is used if we wish to upload images or other media as part of our interactions with OpenChat. If you wish to know where these pieces of information need to come from in your running OpenChat environment, you can go to your user profile, scroll down to the advanced section and click bot config, and that's where you can find three of these things: the OpenChat public key, the open storage index canister, and the IC host URL are all in there. Your own your own identity private key is going to be, in the case of an off-chain bot such as this, it'll be derived from a private key PEM file that you've generated. Don't commit this to source control because this is important. This will allow people to impersonate your bot if you leak this, so don't. The README tells you how to generate one of these, but basically you just pull the private key section out of there. So these 4 pieces of information are required to create this factory. Now let's see what this factory is used for. So we've got this create command chat client middleware. What this does, this is a normal Express.js middleware, and Express.js middleware basically takes the request, the response, and a next function. So it does what it does, and then it calls next. So it forms a pipeline. The idea here is that we want to get in before our bot's command handling processing, create a bot client that we can then pass to the command handler. So what this does is extracts the JWT from the request header. Make sure that we've actually got one. We should do. If not, we throw an error. And then we use that token in conjunction with this factory function, create client from command JWT. And that's going to do lots of fiddly stuff for us. It's going to decode the JWT. It's going to verify the signature of the JWT using the public key from the OpenChat backend. And it's going to expose all of the information we need from that JWT, things like the command name, the command arguments, the scope in which the command is being run. By scope, I mean the chat context, so it may be a channel or a group or direct chat, or that information will be exposed by the bot client. And then what we're doing is we're bolting on the bot client instance onto the request so that the next link in the middleware pipeline will have access to it. So that's going to happen automatically for us before we get to our actual logic. So then the next and final link in this root handler is execute command function. So let's go look at that. So this is a kind of essentially a subrouter. We're on the execute command route, and we expect that to be handling all of our commands that have come back from OpenChat. So first thing we do is just double check that we actually have got a client, so that the middleware has done its job. And then we can check the client command name. Have a quick look at that. We'll see that's a string or undefined. I mention that because it's worth keeping in mind that you can build an instance of the bot client with or without a command JWT, and we're going to see a bit of how that's done later when we're operating autonomously. So you don't necessarily always have a command, and therefore you don't always necessarily have a command name. Sometimes that will be undefined. So then we're just checking which command we're dealing with here. We've got the prompt command and we've got the imagine command. The imagine command, we'll just ignore that for now because it's essentially the same as the prompt command in most interesting respects. So then if we find that the command name is prompt, then we'll just route it through to the prompt handler. Let's go look and see what that does. Okay. So again, we extract the client from the request. Still there, waiting for us. Then we create we want to return and give feedback to the OpenChat front end as quickly as we can, just so that the user knows something is happening. It's quite typical for a prompt to an LLM to take some small amount of time to process, so we'll just say that we're thinking. So that's what this first few lines is doing. It's creating a placeholder message, create text message thinking. We set the finalized flag to false, meaning this isn't the final message. This is a placeholder which will be ultimately replaced with the answer that we get. And then we send that straight back to the OpenChat front end. So that's going to happen very quickly. OpenChat will get that feedback very quickly and be displaying thinking on the screen. Next, we need to find out what the prompt was, and we do that by asking for the string argument with the name prompt. And this refers back to our definition. So if we look at the definition of our prompt command, we can see that it has a single parameter, and the parameter name is prompt. And it's required, so we know it's going to be there. That said, the bot client doesn't know it's going to be there, so the type that comes back out of this string arg function is string or undefined. It doesn't know for sure it's going to find the argument you're looking for, so be defensive here. Check that you've actually got the argument that you asked for. A couple of things you can do if you don't get the argument that you asked for. You could either do what I'm doing here, which is to send back a bad request response 400. Alternatively, you could send back an ephemeral message, which is a message that only the user who issued the command sees. It's quite a good thing to use in case of a validation error. The choice is yours. So if assuming we've got the prompt, we now to make a convincing chatbot, we're not just responding to a single message. People expect to be able to have a kind of conversation with an LLM, and that doesn't happen automatically. You have to send the history of the conversation off to the chat, to the LLM. So in order to do that, we need to have a look back in the context of this chat so that we can provide that information. So that's what we're going to be doing next. So the first step is to call chat summary. Note there's no parameters here. That's because when we created this instance of the bot client, we provided the command JWT, and the command JWT encapsulates the scope in which it's being run. So it already knows that the chat we're talking about. So we just have to call chat summary. When that comes back, we should have, we just check just to make sure it worked. Assuming it worked, what that chat summary gives us is the latest event index, and that is the identifier of the final message that has been sent in this chat. That allows us to then call chat events. And we're going to, there's a few different ways you can call this. You can either get a page of chat events from a start index, either going backwards or forwards. And that's what we're doing here. You could also ask for a chat events window starting, pointing at a midpoint of a particular index. And then it will just get some events before that index and some events after that index. Or you can get individual events by index, where you just pass in an array of indexes. In this case, we just want to get from the most recent, we want to just go back in time a little bit and get a chunk of the previous messages. So that's what we're going to do. Starting at the latest, sending false, which means we're going back in time, and then we just limit it to a maximum of 50 events and a maximum of 20 messages, because we don't want to be sending too much information to the, otherwise we're going to blow our token budget and things are going to get expensive. So when we get a response there, again, we just check that it's successful. We're going to reverse it because we want to feed the messages into the LLM in the right order. We're going to filter through this and make sure that we're only pulling out text messages. I mean, we could be a little more smart because this is going to ignore like image messages with captions and stuff at the moment, but just keep it simple. Now, when you send a message, we're using OpenAI APIs here, and you provide context in this format where each parameter has a role and some content. And the role, given it's a conversation between you and the AI, is either the user or the assistant. So we're just checking for each event to see, was this event sent by, was this message sent by me, the command initiator? If it was, we push it in as a user. Otherwise, we assume that it was a message that came from the AI, and we push it in with the role of assistant. And then it builds up our list of previous messages in this conversation, and then finally we just push onto the top of that stack the next question, the prompt that the user sent in with this command. And then we call ask OpenAI, and that's the kind of boring bit where we interact with the actual OpenAI API. And here we give it a little bit of prompting of sort of what kind of system this is, how we want it to behave in general. Like if you don't modify it at all, you're going to get quite long answers, and it's going to just tend to give you big bullet point lists, which I don't know, just found it easier to make it a bit more brief. So that's what this system prompt is doing, and then we just squish on all of the messages that we built in the last step, and then we get back the next answer. So then we obviously need to then send that answer as another message into this chat. So we create a text message with the answer, or some boilerplate text if we didn't get an answer for some reason. We set this to be finalized true, which means this is going to be overwriting that thinking placeholder that we created earlier. We set block level markdown to true just in case the LLM comes back with markdown, which it sometimes does, and then we send the message. Okay, so that's pretty much it. Now, just to show that it does maintain the context here, we can kind of ask a follow-up question that's a bit vague, but obviously does refer to the first question. So out of the blue, that question wouldn't make any sense. But it knows I'm talking about the internet computer because it has the history of this conversation. So that gives us a good idea of how a relatively simple command exchange works. Now, where did these reactions come from? You can see if I hover over it, it says OpenAI reacted with globe. Now that means it's listening to our messages, and that's because we've listened out for certain events that are happening within OpenChat. So if we go back to our schema, we can look at the description, the subscription section, and we're saying that we're listening out for chat messages, and we have asked for the autonomous permission to react to messages and read messages and delete messages. Okay. So that allows us to do some quite cool things. We go back to our main router. Let's see, we have this notify endpoint. And let's see what this does. When you expose this notify endpoint, OpenChat will send certain events to this endpoint. It's going to send a few events by default, which you can subscribe to if you wish in your bot, or you can ignore if you don't need them. Things like when your bot is installed into a particular location, then you're going to get a bot installed event. That's very useful if you need to keep track of where your bot is installed and what permissions it's been granted in those locations. So you can listen out for those events, and you can kind of save them in a database somewhere, so that when you're operating behind the scenes, let's say you're doing some kind of scheduled functionality like a reminder bot or something, it's going to have to be able to find out all of the locations it's installed in, and then check what it needs to do for each of those installed locations. So install events you can listen for. Uninstall events, obviously, you don't want to be sitting there autonomously working away on some sort of job when the bot's been uninstalled. So uninstall event allows you to clean up your own internal state. And on top of those kind of lifecycle events, you've also got chat level events and community level events that you can listen out for. Not 100% sure which ones of those are developed yet, but we're going to be fleshing that out very soon. So let's look at what I'm doing here. Now the request body is going to contain a notification of some kind if this notify endpoint gets hit. So the first thing I'm doing is parse bot notification. This is a function that comes from the SDK. So it'll do the work of trying to understand what this notification is for you. Again, if you want to know the types, you can just drill into it using your dev tools, and we can see that we get a bot event result. It's either a parse failure if it for any reason doesn't understand what's arrived. That shouldn't happen, obviously. If it does, it's probably a bug on our side. Or we'll get a bot event wrapper, and this tells us a couple of useful bits of information. The API gateway. Not all bots will be talking to the same canister. That's the only reason we need to be told this API gateway. This is a kind of important piece of information for the routing of our subsequent interactions. And then the event itself. And the bot event, it may be a chat event, like I said, or a community event, or a lifecycle event. I mentioned those lifecycle events. We've got removed, registered, installed, or uninstalled. And then chat events. If we look at the chat event type, see, I've only got message filled in at the moment, but we're going to flesh out this the SDK for all of the other available message types. So it's just a temporary thing that this only contains message. So let's back up and proceed. So once I've parsed that, I'm interested in this bot, I'm interested in messages, chat messages. So make sure that what I got back is a bot event wrapper. Make sure that the event kind is a chat event, and it's a chat event of type message. Everything else I just ignore. So given that I've got that type of event, I can extract the event index. I'm going to create a chat action scope. So this is about telling our bot client factory exactly what we're trying to do, what kind of bot client we're trying to create here. And most important piece of information there is in which scope are we trying to operate. And we know that from the event because the event contains the chat ID. So that basically tells us this is where this event lives. So that's the scope that we're going to create. It's a chat scope, and it's a chat scope dictated by this chat ID. And once we've got that scope and we get the API gateway from the event wrapper, then we can use this other factory method, create client in autonomous context, and we pass in the scope and the gateway. Previously, we had used the factory method create client from command JWT. In this case, we haven't got a command JWT because we're not operating in response to a command. We're operating in response to an event. So those are the two scenarios, the command scenario and the autonomous scenario. They both result in the same thing, this client library that's going to help us with the rest of our job. So once we've got that client, we can call chat events. Now, in our prompt command, remember we were calling chat events and asking for a chat events page. In this case, we're just trying to load a single event. So we use chat events, and we use the chat events by index variant, and we provide just this single event index that we have been notified. So the notification doesn't give you the full event. It just tells you that this message arrived, this event arrived. Then it's up to us to go get the full details of that event if we want the full details of that event. In this case, we do. So let's just assume that worked. If the event comes back successfully, we're just double checking here that it's actually refers to a message and a text message. Again, this is, your bot may wish to do something a bit more sophisticated than this, but that's what we're doing here. And then we decide what we want to do with it. So you can see, in our case, we're reacting. And just to show you that this is nothing to do with the prompt command itself. This is just any message that's sent in this chat. Let's try just an ordinary message. We can see that that has responded with some musical notes. So what's it doing? I'm going to come back to this moderate thing in a minute, show you a second example, but first of all, let's look at this React. The React example takes the bot client we created and it takes the message that we loaded. And it's again going and asking OpenAI, passing the content of this message. But in this case, we are saying to OpenAI, respond to any text you're given with a single emoji that you think best represents the text. Do not use any words at all, just respond with a single emoji. And then whatever it sends back, as long as it sends back something, we use our client to add the reaction to that message. And that's what we're seeing here. So it's picked the relevance of music and it's created a reaction that's suitable for that message, which is cool. So let's now look at this moderate thing. Now, this is interesting. This is just an example of the sort of thing you could do with an AI bot. A lot of chats wish to moderate the discourse in their communities and channels, and usually that's a job for a poor human to do. So what I've done here is I've created an example of a bot that can use the chat rules in order to automatically moderate. So let's see if we can demo this. This group doesn't have any rules at the moment, so if we enable some rules and we say there's some silly rules that are very specific that we can test. Do not mention anything about dogs or the paranormal. Pretty niche rules, but I run a tight ship. So I can talk about normal stuff. It's happy with that. But if I stray into dodgy territory, my message was deleted. Doesn't like that either. So let's see how that works. So it's piggybacking the same notification mechanism. We loaded the message already, but in this case, it's going to send it through a moderation filter first. That moderation filter looks like this. So we load the chat summary. We check if it's a group chat, and it's a group chat that has rules enabled. And then in that scenario, we ask the AI, we send it the rules text and the message content text, and ask, with the system prompt, you're a moderator for a chat platform. Your task is to assess whether a message violates a given set of chat rules. Use only the provided rules. Do not apply any other criteria. Respond only with yes or no. Yes if it violates the rules. No if it does not. Do not explain or justify your answer. This is just, I've been playing with these prompts to see what gives us the best result. And then we pass in the user content is the chat rules and the message. And then what we get back is, if the AI answers yes, then we know that this bot, this message broke the rules. I've got two different modes that this bot can operate in. Either it adds a reaction or it deletes the message entirely, just to demonstrate that it can respond in different ways. Let's just change the mode to react so we can see what that does. Whoops. We'll need to restart. But essentially, it's the same kind of general idea. We use the client that we created in the previous step to either add a reaction or delete the message. So let's try again. I'm not sure why that's not responding as I expect it to. But anyway, you can see from the code what the intention is. The intention is that it's going to react with the old poop emoji if it doesn't like the message instead of deleting it. Once we have filled in a bit more capability, we could have the bot, it could be as sophisticated as you want. You could have the bot reply to the message and say, careful now, you're on, strike one, and then, keep a tally of users and their violations and decide what to do. Give them a couple of chances and then start deleting their messages and then ultimately suspend them. You can make it as simple or as complicated as you like. So yeah, that's basically how this bot works. I hope that gives you a bit of context when looking at this bot sample code. It's a good one to look at because it does cover both the command handling and the autonomous behavior via the notify endpoint, message subscription, things like that. So it's a good one to look at to get an idea of what it's capable of. Feel free to look at the other examples. We've got a bot that scrapes news from the BBC website. We've got a Spotify bot that interacts with the Spotify API and posts Spotify links, and we've got a bunch of kind of miscellaneous things inside this other folder. Hopefully that gives you a good insight into the example code for TypeScript bots, and if you have any questions about it, just get in touch on OpenChat. Bye-bye.